Yeah, make sure you're not muted this time.
Yeah, I already took it off, so we're good.
Well, good.
Okay. So what we're gonna do, gang, is we are going to quickly roll through this lesson, like I said, and then your next lesson as well. We're gonna go quickly through them because we want, whoop, not that quickly, because we're gonna have a little time to do a little bit of review. Wow. You actually have 2 reviews now available to you. Where do you find your midterm reviews? Somebody tell me. Dropbox, right? And what folder? Yeah, it's in the resources folder in Dropbox, and it'll say midterm review, and then you just click through the folders till you get to the one that is the lab rats review, because obviously there's nothing in the junior lab rats review now because we don't have any. So yes, that's where you will go, and there are 2 reviews in there right now. One is the click through and reveal that looks just like our lessons. It's like 150 slides or something. It's huge. But that's because some slides have one thing on them. I like that review because I'm one of those people that if I see a picture along with something, I can remember exactly what that page looked like. Like if I see this, I'm going to remember that, you know, if I study it, I'll see the whole thing in my head. So it helps me to have something like a slideshow versus just like a piece of paper with everything written on it. Right. So there will be a general topic review, just a piece of paper with everything written on it as well. And then there also will be a Jeopardy review. We'll have the Jeopardy review running next week. So next week, it's going to be a super quick lesson like today is going to be, because you're going to watch the other documentary, and then we'll do a Jeopardy review.
What's that?
So Jeopardy review is it's an online app you can use, and it'll put up a Jeopardy screen, just like the game Jeopardy. Have you ever watched Jeopardy?
Yeah.
And we'll split the class into 2 teams, and we'll answer the questions. And it's super fun. And you can do it by yourself as well. Yusuf.
It said it was answer review, right?
Do what now?
The spreadsheet, like the slide said it was answer review.
Yeah, so answer reveal is if you open it in Dropbox and it allows you to open it in PowerPoint or in Google Slides, you can, the answers are covered like in class, and then so you can think about what the answer is before you reveal it to yourself.
How do I reveal?
Just click, it should go. If you're looking in Google Slides or in PowerPoint, it should just click. And if it doesn't work for you, there's one without reveal that is up right now already. All right, so we're going to do this lesson quickly, like I said. So we're talking about, and this lesson is a fair amount of slides, not too terrible, but it's kind of short because we got to get through it quickly. Okay, so we're talking about the oceans now and the marine environment. Now, the movie that we're going to watch during our post midterm Christmas party is The Living Sea. Some of you have seen it if you've been here with me before. It's outstanding because it was an IMAX film, and the reason I even know about it is because all the music was done by Sting, and if you have paid any attention to anything in the pub, you'll know Jason's a big Sting fan. So it's very good, and it has incredible photography. So it'll follow up on our lessons here about marine environment. All right, so oceanography, obviously, is the study of the Earth's oceans. Graphy means to what? Alex?
Normally to write.
Yes, to write. So in this situation, it would be like to write or to map or to study, right? And obviously the ocean. All right, so we're going to talk about data analysis and collection. How do we collect our data? So at the surface, we have something that is sound navigation and ranging. It sends sound waves and uses timing of bounce returned wave to determine depth of distance. Drew. Sonar. This is sonar. Okay. So sonar, which you hear used all the time, just like a word, is actually a word created from the abbreviations of, yeah. Oh, yeah. Yeah. Sonar, sound, navigation, and ranging. All right, so this is when you send a sound wave at something and it bounces back and it tells you the distance. Very similar to like ultrasounds that you get in the medical field, same kind of concept, right?
Or echolocation.
Yeah, or echolocation. And so it gives you an idea of the topography of the ocean floor or whatever you're looking at. So what directs the sound waves to the seafloor at an angle to gather data about the sides of underwater hills and topography? Do we know what that one is?
Angled sonar.
Angled sonar. So it's the side scan sonar. So you're really close. So so sonar's shooting straight down, and it gives you like an aerial view of the topography. And then you have, I gave it to you. And then the side scan is at an angle. So now you can see the sides of underwater features.
Angled sonar.
Yeah, angled sonar, it's side scan sonar. Okay, so that tells you what's on the actual sides of things. So in the deep sea, now we're in the deep sea. So what is this? And vessels, underwater vessels, computers used to produce models. What are you thinking?
Submersibles.
Submersibles. This one right here is a submersible. These are super cool.
Yeah, I was looking at them the other day. They're like stupid expensive for yachts, but they're super cool.
They are very,
like to get one.
very cool. Yeah. And they've gotten, like you said, they've gotten to the point now where you can have like underwater drones of your own, where this used to be the kind of thing where you would go down sometimes in the submersible, like this is a submarine type one, or you could do one that is kind of remote controlled from the top. And like, you've seen the movie Titanic? Anybody seen that? At the very beginning, they're using the submersible to look around the boat. So, what?
Speaking of that, it has actually been proven by the Mythbusters that he did not need to die. He could have stayed on the.
I know. There's so many pictures of like Jack where he could be positioned on that piece of wood that they're floating on. It's great.
He's actually not been.
Jeez, I'm not from the. Okay, so Earth's oceans. So where do oceans even come from? How do we get oceans? So we have some sources of water. So water may have come from a remote source or a local source, such as water that forms from the processes under the earth rising to the surface. Bailey, where? Meteors or what? Comet, same thing. Yeah. Okay. So that's what we're dealing with here. So maybe water came from meteors and comets. Comets are sometimes referred to as big old dirty snowballs that come flying through space, right?
Cosmic snowballs.
Yeah, cosmic snowballs. So we may have gotten our Earth's water from that. We also may have gotten it from processes under the earth that allow it to rise up to the surface. Because obviously it's going to be less dense than rock and whatnot. So it would rise, right? So volcanism, this is cool. If you're looking for an interesting field of earth science to study, this one's cool. So the mechanism by which water deep within Earth's interior is brought to the surface is what? What do we call this mechanism? Does anybody know? Anybody? So this is volcanism. There you go. All right. So volcanism is going to bring magma up and it's going to bring water up. Think about the steam and water vapor that comes up during a volcanic eruption, right? So atmospheric water may have cooled and condensed. And then what? After a period of warmer temperatures and volcanic activity, Piper?
Melted?
May have melted, may have precipitated in this case, but that's fine. So yes, that's what we're looking for. So we've got water that's coming up with volcanic activity and it cools and condenses in the atmosphere and then it precipitates and falls back down to Earth. So that may be a way that we got some of the water here. So after volcanism, Earth's and the crust cooled, allowed formation of our oceans. What do you think is going here, anybody? Parker, did you want to guess? No? All right, Liam?
Earth's atmosphere.
There you go. Earth's atmosphere is going to cool. And then Earth's crust is going to cool. So think about it here. If you have water, all right, down inside the Earth, you have a volcanic eruption, brings the water up to the top in the form of what? What state of matter?
Yes. Water vapor.
Yeah, it's going to be vapor at that point, right? It's going to go up into the air and it's hot. And then after the volcanic activity ends, it's going to cool down, precipitate as the atmosphere cools, come down to Earth as rain or maybe snow, depending on how cold it was, or ice. And then you get puddles of water that start to form. Okay, so there's be a lot of volcanoes, right? So some ancient lava flows have glassy crusts that form only when lava is cooled rapidly underwater. Remember when magma cools quickly, you get glassy, yeah, like obsidian. It's not cooled slowly because there aren't visible crystals. So if a scientist knows how old the lava is, he or she can infer that the oceans have existed for at least that long. Okay, we're seeing this thought process through. So how does the water get to where the water is? How is it distributed? So the oceans contain 97% of the Earth's water And what sources contain 3%? Yusuf. There we go. All right. So fresh water sources are in 3%. Yeah. Shouldn't say contain there. It's kind of, yeah, but you're getting it. You're getting at the right point. So if you look at Earth, like that big picture Al Gore showed from the spacecraft from Apollo, this big blue ball, 97% of it is salt water. Only 3% is fresh water. So 97% of it, we can't drink it, right? There's only 3% of Earth that's gonna be.
You could purify it.
Yeah, you would have to do desalination and whatnot. There is one country which has managed to actually make desalination of ocean water on a grand scale a functional and feasible thing. It's actually that's how they get most of their water. Do you know which country it is? Does anybody know? Jack?
That would sound like India.
Not India, but good guess. James, it is Israel, right? So Israel has managed to do desalination on a large scale, and it is successful and sustainable. For most places, it's not. Because people all the time like, oh, well, if we have a water shortage, why don't you just, go use desalination? Because it's not sustainable in most places due to many, many reasons. But Israel has mastered it. So, what percent of salt water is the oceans? We just said this. Who remembers? All right, Parker.
93.
Close. Okay. So 70, I should say 97. That's a typo. Sorry, I'll fix that. So 97, you're very close. And then what percent is fresh water? We can do math. Jack, you go.
3.
All right, there you go. 3. I got to fix this one real quick. That's a mess. So let me fix that because that should say 97. That's a big mess. That's a typo. 9. Yeah, except I caught it. So yes, I caught my own brownie point. So yes, we're dealing with very little fresh water, like we said. All right, so the blue planet. What percentage of the planet is covered in water? Bailey.
71%.
Wow, right on. And it's a weird number. If you can remember roughly 70%, you're good to go. You don't have to remember. 71 is very specific, but yes, roughly 70%. So you could also think to yourself, almost 3/4, because that's 75%, right? So
Would you accept 70-ish?
I would expect 70-ish for sure. All right. So what percentage of this water is in the northern hemisphere? All right, Chloe. 60-ish. Yeah, 61. Again, that's a weird number. 60-ish. Yep. So about how much percentage wise if we were going to make it an easy fraction, Drew?
40.
Oh, no, I'm not on the next one. I'm saying if good math though, I'm saying if it's 61%, you could say what is the fraction that would be easy to do, Alex?
6/10.
Yeah, well,
Well, just under 2/3.
yeah, I would remember about 2/3 because 2/3 is 66%, right? That's an easy one to remember. All right, so 60-ish. All right, so Andrew said 40-ish, and you're right. But what I was looking for is 81%. So the way this is it's 61% of the northern hemisphere is covered by water. 81% of the southern hemisphere is covered by water. This isn't, I phrased it incorrectly. This isn't what percent of the water is here versus what percent of the water is there. It's what percent of this hemisphere is water versus this hemisphere. So there's more water where? Which hemisphere, Drew? Yeah, southern hemisphere has a lot more water, and that is just the way Pangea worked. Oh, it's silly those continents don't fit together. What a silly question. We've learned, right? But if you look at just the way the tectonic plates have moved, it's just the way it's ended up. So the average ocean depth, who knows how deep the ocean is, Milo?
3,800 meters.
Oh, yes, 3,800 meters. That's about 2.36 miles. So about two and a third miles. So next time you're in the car, okay, like when you're leaving, not when you're leaving here, because you're winding around. Next time you're on 400 or someplace that goes straight for a long time, you've heard highway, okay? Ask your mom or dad to start tracking the odometer at a certain point and to tell you when you've gone about 2.3 miles. You'll get an idea of exactly how deep it is. That's very deep when you're talking about straight down, okay? So roughly half of all of our seawater is contained in which ocean? Ooh, lots of hands. All right, let's do it, Lil.
I had an idea, but I'm afraid I'm wrong now.
Say it. Doesn't matter. Pacific. All right, you're right.
And deeper than the Atlantic as well.
Yes, Pacific's huge, right? It's huge.
It's
Uh-huh.
also got more lava and volcanoes in it because of the ring of
Yeah, Ring of Fire. So, I mean, look, it's huge. Like,
fire.
here's the Atlantic in between, but then look, the Pacific's all of this. It's a lot. It's a lot.
Like what?
Yep. So global sea level. Okay, here's our Al Gore comments. Today, the what do we think of glaciers is causing a slow rise in the average global sea level. Well, lots of hands, James. Melting. All right. So we have our glaciers melting. He showed those scary pictures of all the water glaciers crashing off and the polar bears drowning, and oh, it's awful. So that's terrible. We don't want all that to happen. So
A little bit of glaciers falling apart is normal. That's gonna happen eventually.
absolutely.
But the rate.
The rate, right? That was the concern, right? So it is causing a rise in global sea level. But so let's think about this here to give you an idea of where we start. So the level of ocean surfaces, where do we consider that altitude wise? When we're doing altitude, like at sea level, what is that measurement? Alex?
0.
Okay, that's gonna be 0. Okay, so if you say you are 100 feet above sea level, you're measuring the level of the ocean as 0. And the level of the ocean on the Atlantic coast, the Pacific coast, on the coast of the Indian Ocean is the same everywhere, right? Because it's like if you took a big bin and you put water in the bin and then you put a bunch of buckets in the bin, the water is going to be at the same level on all those buckets, right? Or anything, rocks, whatever. That's just the way it's going to work. So if we consider that as 0 when you're standing at the ocean, the average global sea level is rising by a certain amount. Do we know what, Yusuf? What is it? By how many? 2 feet. Okay, per year. Do you know? So it's in millimeters, Jack. Do you know?
Gosh, I had it. I'm gonna say,
Go wild guess.
okay, well, guess 7.
Okay, so it's actually rising by 1 to 2 millimeters per year. So think for a minute. Millimeters are. All right, here's your millimeters on this side. This is a centimeter from here to here. Okay, so 1 to 2 millimeters would be from here to there. Okay, rising by that much per year. Everybody see it? Is it a lot or a little? It's a little. Over time, it can get to be a lot, right? So that's what we're dealing with, is this very little movement in rise at the moment. So during the Ice Age, what happened to our sea levels? Anybody know what happens to sea levels during an Ice Age? Jack, do you know?
It went brrrr.
It went down. Okay, Jack says it went down. All right, Jack's right. It did. They did drop. So let's think for a moment. Global sea level is going to do what in response to the melting of glaciers? It's going to do, Chloe? It's going to rise. Okay, so why during an Ice Age do the sea levels drop? Ooh, Yusuf.
Because the ice freezes and ice melts. I mean, ice.
Right,
falls
because
down.
the water is in the ice, right? So
There's
you're
an ocean if there's no water.
Uh-huh.
With water.
Yep. It's all going to becomes the ice, right?
All
right, so-
want to go around to make the ocean.
Our major oceans.
We have 8 billion people now.
So which ocean is closest to us? James, that would be the Atlantic. Very good. Which ocean is the largest? Drew, the Pacific. All right.
What's the smallest?
Yeah,
It's blocked off. It says smallest. Which one is the smallest? Lily? No? Yusuf?
Arctic.
Arctic? Indian. Close.
Same.
Indian. Indian is the smallest because now we're going to go to the polar oceans, right? Okay. So They're cold, they're slushy, they can be covered in ice pack. So the oceans around Antarctica are known as what?
Arctic.
Arctic oceans. Okay. Southern Ocean is also Antarctic Ocean, right? Okay. And then near the Arctic Circle, this is the Arctic Ocean. So what's the difference here? All right. Where's Antarctica?
South.
It's south. Okay. So what do we call this ocean here around it?
South.
This is the Southern Ocean or the Antarctic Ocean, or sometimes the Austral Ocean. I don't hear that one very much. So this down here is your Antarctic or Southern Ocean. This up here is which? This is the Arctic, and you can actually see this one is has more borders. See all the land around it? You can kind of go, okay, that's the Arctic, like the coast of, what is that? What was that place called? Prince Patrick Island in Canada. It's on the Arctic Ocean, correct? But down here, it's not quite as clear because it just kind of turns to ice and spreads out.
But isn't the Arctic Ocean part of the Atlantic?
It kind of is. They bleed right into each other, don't they? There's no real, I mean, I'm sure there's a defined border that somebody has decided, but when you're looking at it, it's not real obvious. The big ones are your Atlantic, your Pacific, the Indian, and then the Arctic up here, right? Okay. So keep that in mind. I almost put him away when I was putting out Christmas stuff. I was like, cleaning off stuff because I can't stand having too much at one time. I almost put the globe up and I thought, no, I'm going to use that son of a gun. So yeah, I could put a Santa hat on it. I probably should. Oh, by the way, now that we have Christmas out, y'all could look for Gerald every week. He's always gonna be somewhere. Does anybody remember what Gerald is? Yeah. What's Gerald? He's my elf. Yeah, he's our elf. He comes out at Thanksgiving. He's late this year, but yeah, he's hanging around somewhere. So you'll find him every week. It's just kind of the thing. You don't get a prize for it, but it's always fun to look for. All right, so oceans and the atmosphere interact. All right, so dissolved salts and nutrients are present in seawater in the form of what, Liam?
Salt.
In the form of salt. You're close. In the form of ions. So what's an ion? Can somebody tell me what an ion is? Where is your thing, Liam? I can't remember where everybody is yet. Oh, there you are. Ion is, all right, Alex, you do it.
A small, either atomic or molecularly sized particle, depending on which ion it is, that is charged, either from the addition or loss of an electron.
There, so that's what we're dealing with. An ion is, you've got a molecule or an atom that's supposed to have a certain number of electrons to have no charge, right? And sometimes you lose or gain an electron. And then you become an ion. And that means if you've lost or gained an electron, that you have a charge now. You're either positively charged or negatively charged. If you lose an electron, which are you, positive or negative?
Positive.
Positive, there you go. Okay. And that's because electrons have what charge, Bailey?
They have negative charge.
They have a negative charge. Okay, so if you lose a negative, that makes you more positive. All right. Now, the reason this is important is because ions, they're good at interacting with other compounds, but they also are good with electricity. Like you have to have ions if you're going to have electricity traveling. That's why if you have salt water, it's going to conduct electricity better than water, right?
Pure water with nothing else in it does not conduct electricity.
Not at all. Yep, you gotta have some ions in it.
It can insulate later.
Yep, well, you do a really good job. If you put some salt in it, it'll do a great job. All right, so they're in ions, and that's important because like what I was just saying. So sources of atmospheric oxygen. So marine phytoplankton release oxygen as a byproduct of photosynthesis. This one is important to remember. The greatest source of oxygen on the planet is marine phytoplankton. Not the trees in the Amazon. They are not the lungs of the planet. The lungs of the planet are little itty bitty phytoplankton hanging out in the ocean. Predominantly, they're super important when they're right here-ish. There's a lot of them right in here where you've got what we've got here. Got a current going, right? They kind of go this way. And then the Amazon River over here actually has like because it's so large, it causes a disturbance in the atmosphere above it that helps actually bring some of that oxygen right over and in here. So yes, there are phytoplankton everywhere. If we lose phytoplankton, we probably aren't gonna survive, but yeah.
Almost all of the oxygen created in the Amazon does not leave the Amazon.
Correct. It's used right there. So the phytoplankton are super important.
All the frogs and the like.
Yep. Now the oceans are also not just sources of atmospheric oxygen, but the oceans are reservoirs of carbon dioxide. So when oceans cool, the dense surface water containing carbon dioxide sinks to the bottom. Now, this is yellow because you need to remember this. This one is something to remember for life. I should have put a Rico on here. And in context of today's documentary and next week's documentary, this is a very important point to understand. So carbon dioxide is more soluble in colder water, less soluble in warmer water. This is a general rule for gases. Gases are more soluble in cold water than they are in warm water. So think about this. If the oceans are cold, they cannot absorb as much. I mean, they can absorb more carbon dioxide. If the oceans are warm, they're not going to be able to absorb carbon dioxide. So think about what that means in context of what Al Gore was saying. We have all this carbon dioxide in the atmosphere and the planet's warmer. So if the planet's warmer and the oceans are warmer, they cannot absorb more carbon dioxide. If they were cooler, they could. All right, keep that in your mind, because next week you're going to be like, what? Okay, there's going to be a moment.
Like global warming, right?
Yes, exactly.
Heats the ocean, which means he can't.
Right. Right, exactly. Okay, so keep that in your mind. All right, sources of heat and moisture. The oceans are also sources of heat and moisture. So warm equatorial water heats the air above, fueling tropical cyclones. Woo! So we all know about those because we get the remnants of them here. I will note.
After they hit Florida for the time.
So Katrina here. Y'all saw some of the footage of Katrina. Most of you were either infants or not born. So Katrina came in 2005, and I will never forget that it was 2005 because Cole was like weeks old. And I was watching the news. I think Katrina came in. Alexa, when was Hurricane Katrina? It's like September.
Hurricane Katrina began on August 23rd, 2005,
okay, end of
and
August.
ended on August 31st, 2005.
So Cole was born the first week of July. So he was tiny, right? He was tiny. And I remember watching these videos of these people in just terrible situations. They let everybody into the big like Superdome area. And then there was terrible stuff going on in there because you could not manage that many people. And it's like, when you get a whole bunch of people together and everybody's stressed, bad things go down. People are not on their best behavior. So there's stuff going on in there. The biggest tragedy, I think, of the whole thing was buses. If you want to look up something really interesting, Al Gore is specifically using Katrina in this documentary to talk about global warming and shows you the devastation and then shows you about people. Yes, there was property damage that could not have been prevented once that hurricane was coming. However, they had school buses lined up to evacuate people. And there were problems with the buses getting there. There was footage of those buses sitting in parking lots completely flooded. They did not get the people out. He didn't mention it for a reason. If you look at political parties and who was responsible for moving the buses, that might help you. So it was just the whole thing was a disaster. It was very chaotic. People probably could have gotten out if the buses had been used, but they weren't. So I won't forget that ever, because one of the things, I was sitting on the couch nursing Cole. He was tiny, and I'm watching this news coverage, and there was a lady on a bridge, because she was as high as she could get, like an overpass bridge. Everything below her was flooded. She was sobbing, and she had an infant, like 4-day-old infant in her arms. And this baby was floppy in her arms, like terrible tone. You're looking at that baby and you're like, that is not good. That's not how an infant should ever look. And she's sobbing because she couldn't feed him because she'd had no water herself for like over a day. And it was killing me. I was like, oh my God, somebody please give that woman like 4 or 5 water bottles immediately. There wasn't any. And every time a hurricane comes, that image flashes in my head, because I was sitting there feeding my baby and he was home and healthy. And there was this woman who could not take care of her child. And it was really scary. So oceans are good for all those reasons: absorbing carbon dioxide, producing oxygen, all that good stuff, sending storms, which isn't great. Seawater. All right. Seawater itself contains dissolved gases, nutrients, nitrates, salts, and phosphates. So what is the term for a measure of salt in water? Milo. Yes, salinity. Okay, salinity is the word for how salty is the water. All right. So seawater is going to have an average about what percent? Chloe. 3.5% or 35 parts per thousand. So 3.5% doesn't seem like a lot, right? I mean, you got 96.5% of your water that doesn't have salt in it. But if you've ever tasted ocean water, you know, it's still pretty salty already. It doesn't take much for it to become salty. And this is what makes it, you know, we can't drink it. We can't function off of it. We need that. Getting all that salt in your body is not good. All right. So variations in salinity. So where precipitation is high or near the equator, or higher in the subtropics, what happens with the salinity in those areas? Do we know? Bailey, do you know? Okay, very good. So it's lower because it's diluted. She gave us the answer right there. It's diluted because there's more rain. More rain, it's going to dilute the salinity. That makes sense, right? At least in the surface levels of the ocean. Not going to mess too much with what's below it. But if you've got like a giant hurricane blowing over the ocean, dropping fresh water on it, it's going to dilute at least those top layers. So what happens in the polar regions with salinity? Do we know? Melting ice? Chloe? There you go. Same concept. It's going to be lower because it's diluting it again. You've got polar regions where your ice is melting into the water, and that water is then going to be, of course, less salty. All right. So where freshwater and seawater mix, Alex?
Mainly areas such as a river delta.
Yep. Okay. Or estuaries. Yep. And that's where you have the lowest salinity. And the word for that is brackish water. You ever hear about brackish water? It's water that is part salt, part fresh. And that's what you find in...
It's where salmon hang out in order to acclimate to freshwater or seawater.
There you go.
Because they can do either. Just if they go from one to the other rapidly, they die.
Isn't that crazy?
They just have to get their bodies used to
Yep. So that's where brackish water, you'd find it in estuaries, you find it in river deltas, you find it in marshes.
It's like with the salmon, like smoking, like some, like kind of, if you go quickly, like you die and then you get tired.
I don't know about smoking in particular, but withdrawal. Yeah, withdrawal. Yeah, there you go. Smoking, you just get really angry with everybody around you.
I missed the first part, so I was thinking that you had
I
said
confused
salmon.
two of my questions together.
So I did
Y'all are funny. Y'all didn't grow up in the
Floated around with cigars.
y'all didn't grow up in the time period where everyone smoked all the time and then everyone tried to quit. Some of us have lived through that, and we know exactly how mean people get when they decide to quit. I mean, we grew up, as like you said, the tobacco industries, right? They knew for a long time that what they were doing was very bad. They actually advertised and said it was not bad, even when they had studies to prove that it could cause cancer. They knew it.
In the
And-
60s, your doctors used to smoke wicked. I mean,
And there's been all kinds of legal ramifications. If you watch any of the old clips of like Johnny Carson, there's smoke in there on the set with him. So those of us that watched people quit smoking, my dad did a weird thing. He put a rubber band on his wrist, and anytime he felt like smoking, he'd pull it back and snap. He was punching himself. I don't know what he was doing. So yeah, and then he went from cigarettes to a pipe, and then eventually gave up the pipe. So sources of sea salt. So what is this that releases chlorine gas and other elements from weathered rock combined with chlorine and other salts? What are you looking for, Alex?
I think you missed the box.
Oh, did I? Oh, I did. I'm sorry. The freezing point of salt water is what? Than fresh water.
Somewhat lower.
Okay, somewhat lower. Okay, why is that important to know when you're talking about just like day-to-day life? Where is an example of where you know that if you put salt with water, it's going to lower the freezing point? Anybody know? Bailey, do you know? It also lowers, very good. It also lowers the boiling point. Yeah, so what is it about putting salt in water when you're boiling it? What are you doing there? What are you trying to do? What's gonna lower it's gonna make it, actually, it's gonna make it cook. It makes it cook hotter. Basically, it makes whatever you're cooking cook hotter.
Another useful usage of this is in the wintertime. Salt is used on the frozen roads
Yep.
when there's snow because it'll melt the ice.
Yes, right. Okay. Very good. All right. So where do we get sea salt? What's the first one? What do you think? Yusuf.
From the ocean?
What in the ocean is gonna cause what's coming from rocks? Do we know what it is? Do you know what that one is? So this one's a little tricky. This one is volcanic eruptions. Under the ocean and above it are going to release chlorine gas, other elements from the rock. It's going to combine, other elements are going to combine with chlorine and produce salt. What is an example of an element that can combine with a chlorine ion and produce a salt? I got one hand. Give me a couple examples. Alex, give me one.
Potassium.
Potassium, you get potassium chloride. Okay, that's KCl, right? We've used it in a lab before, James. Sodium, James, what does that make? Salt, what kind of salt? Table salt. All right, if you are looking for one of those low sodium salts that they tell people with heart problems to use, it's usually potassium chloride. If you put salt on your table and shake it, that's sodium chloride. Use it.
Nitrogen?
No, I don't think that one will do.
I know.
That's good. You're fine. All right, do you have one more?
I believe iodine.
I think you're right on that one. Yeah. All right. The big ones for you to remember that are going to be part of your day-to-day life: potassium chloride, sodium chloride. All right. So the removal of sea salt, organisms can remove salt from water. And then what do they do with it? Do we know? What do you think, Piper?
Build up shells.
They build their shells and stuff. That's right. Exoskeletons. So yeah, you're going to have certain organisms that live in the ocean that are going to, part of their living process is to remove the salt from the water and use it to create their own bodies. Pretty cool. Use it in bodybuilding. Yes.
Can we lick the bodies and taste the salt?
I don't know, but I went to what's that place? The Shuckin' Shack. It's over across from the collection. It's where Dickie's Barbecue used to be. Anyway, it's in the corner there. And they have good seafood, which is hard to find around here. Used to be Martin's Landing in that area, and that got knocked down, and that was all seafood. I was sad. Anyway, Shuckin' Shack, you can get this thing called somebody's pot. And it's a big old tray, and it's crab legs, it's clams, yeah, something like that. It's crab legs, clams, shrimp, and then you can get oysters, raw, fried, whatever. I love me some raw oysters. But yes, if you suck on a king crab leg, it's going to be pretty salty. I don't know if that's coming from the shell. It's probably just coming from the fact that you live in the salt water, right? All right, so density. Salinity affects the density of seawater. Density differences in the is the main cause of ocean what? Because cold water, which is more dense than warm water, sinks to the bottom, while less dense water is found near the surface. What do we call this cycling of water? Alex, you're the only one with the hand up.
I'm not sure if it's what are looking for, but it's a current.
Okay, what were you gonna say?
Ocean current.
You guys are close. So we're talking about layering. So it's called layering. So yes, if you have salt water, is it going to be more or less dense than pure water? Just answer.
More.
Okay, more dense. So where's it gonna go? Sinking or rising?
Sinking.
It's gonna sink. And also, if you have cold water and warm water, which one's more dense?
Cold water.
Why?
Yeah. Not bouncing around.
Right, so it's gonna sink, correct? All right, so you have at the very bottom of the ocean, what would you expect the water to be like with regards to salinity and temperature? Piper, cold and very salty. Piper, spot on. All right, so thermocline. All right, so transitional level in which what is going to decrease with what? Oh, come on, somebody can do it. Somebody who hasn't gone yet. What do you think, Sky? Yeah, a layer in which something is going to decrease along with something else. What's the graph showing there?
Red lines.
The red line, yeah. So is it getting, so what's
Little
decreasing
line.
there? If you go down into the ocean, deeper and deeper, yeah, pressure, also the depth, right? And then what's the temperature going to do from top to bottom? Is it going to get, it's going to decrease, right? So as your temperature decreases with your depth, this is called the thermocline. And they've got layers of it to kind of tell you what goes where. So what's important to remember about that is that just as Piper summarized for us, as you go down, it's going to get colder. It's also going to get saltier, right? Okay. So both the thermocline and the surface layer are absent in high altitudes like the polar seas, okay? So the polar seas, it's saying their altitudes are a little higher. Basically, it means they're like more shallow.
Just want to say thermocline sounds like either a medicine or
It
the type
does.
of product you would see on
Right.
one of those old
Right.
infomercials.
If you just saw the word,
Thermocline.
if you just saw the word thermocline, And you had to figure out what it meant. What clues would you use to figure out what it meant?
Well, obviously, it has something to do with heat from
Thermo, temperature or something. And then the cline. What does that sound like to you?
Incline.
Incline, decline. Yeah.
line and
I know that like at the bottom of the ocean, so the bottom of the Mariana Trench, the pressure is crazy because of all the water, but how come is it hot because of all the pressure flowing water?
Okay, so there are areas that are hot, pockets in general. So yes, very good, Drew. So along the Marianas Trench, which is the big mid-ocean trench, right? You've got a lot of volcanic activity. You've got a lot of deep sea vents that are all letting out very hot gases or magma. Those areas, those little pockets are going to be very warm. Yes. Friction of what?
It's like here it's cooler down here because all the pressure on the air model, right?
Compared to where? I'm trying to follow you. Compared to up high, yes, because the pressure is greater. So there is friction. So you're saying friction in water molecules. Why isn't it? Because there's under more pressure. That's a very good question. So the water molecules, when they spread out, right? Like when they get warm, they spread out because they're moving around more, and then you get more friction. When they when it gets cooler, they condense together and they're moving, but they're not moving like this. They're moving like this. So there's not as much opportunity for that bumping around. Does that make sense? Cool. All right. So ocean temperature. What's the average in Celsius? Anybody know? The average ocean temperature.
21.
21. James? 15? Everybody's guessing. Yusuf?
20.
20.
Old Faithful 42.
All right. I'll give you the last one, Jack. What's it?
42.
42. James, it's 15. 15 degrees Celsius. All right. Oh, Alexa, convert 15 degrees Celsius to Fahrenheit.
15 degrees Celsius is 59 degrees Fahrenheit.
You want to swim in that?
No.
I don't. The water near the beaches is going to be warmer. Why? It's a beach, but why is it going to be warmer?
Shallower.
It's more shallow, so you're sinking in. Also, it's moving, so this shallow water gets warm and it gets pulled out and it cycles around, right? Very good. All right, so cold water and water masses. So intermediate water masses, and what do they do in temperature and sink? If they're sinking, then what's happening to their temperature? Bailey. They're decreasing in temperature so that because they're sinking. All right, makes perfect sense, right? Bottom layer of the ocean. Water is formed in what seas? Think about it. We just said it was cold water. Where is it coming from, do you think? If it's sinking all the way down. Think about it, Drew. The poles, you got it, right. So the coldest water in the oceans is coming from the poles, right? And it's sinking down underneath everything else because it's very cold. And now the water in the poles might not be as salty because the ice is melting, right? But there's still salt interacting and coming all the way down from the top. So the coldest and densest water mass in all the oceans is what? What do we call it? Yusuf? Can we know? Alex, do you know?
Cold and salty.
Cold and salty. Antarctic bottom water is the think about it. Funny word for it, but that's absolutely it. Okay, we're going to keep moving because I'm watching time and I want to be sure you have a little review time. All right, so the absorption of light. So light penetrates about 100 meters. That's not too far. So which end of the spectrum, think about your electromagnetic spectrum and your visible light, which end is going to penetrate deeper? Okay, Yusuf.
Blue light.
Blue light's going to penetrate deeper than
Red light.
red light. Okay, very good. Blue light is going to penetrate deeper than red light. Okay, I have to tell you something really cool about blue light that I just learned. So this is really neat, really neat. So my father-in-law, what was his job? You guys know. What was his job for years? I showed you a video of it.
Pilot.
He was a pilot, a fighter pilot, right? Okay. So his vision has always been super important. If you're going to be a fighter pilot, you got to have 20/20, not correctable 20/20 period. All right. So as he's gotten older, though, he got reading glasses. Everyone does. Yeah. And then he had to have cataract surgery. Okay. So he had cataract surgery a few weeks ago. So cataracts are when the lens in your eye starts to kind of get cloudy over time, and then you can't see as clearly. It's like you're looking through something. Yeah, it's like you're looking through something that's kind of like translucent,
Like fog.
blurry.
Like
Yeah.
dirty glass.
Yeah, like you're looking through foggy glass or something, right? Okay. So it obviously affects your vision hugely. So what they do with cataract surgery is they go in and they actually pop out your lens, which if you've ever seen a human eyeball lens, it's actually kind of firm. It's like it's kind of weird. And then they put in a prosthetic lens and poof, you can see beautifully again. Okay. As soon as his prosthetic lens was in, they put the patch on his eye because you can't touch it for a while. He could see out the little holes in the patch. And he was freaked out because all he could see was blue light, blue stuff, weird blue stuff. And then when they took the patch off, he was really afraid because everything he looked at was bluish. And everything seemed to have like he was looking through a blue lens. And it weirded him out. Well, here's why. Because, careful, don't do that, breaks the chairs. So over time, he was absorbing less blue light because of the cataract. It doesn't go very far because of the cataract. So because he was absorbing less blue light, his brain looked at the world around him and was like, well, that's supposed to be bluer. And his brain saw things the way they're supposed to be, but not the way they were physically coming to his eye. So his brain had adapted to less blue light and everything looked normal. So when they popped that cataract out and put the lens in, his brain was like still trying to think that it was thinking of more blue light that wasn't there. And everything was blue. And it'll take time for his brain to adjust again. Fascinating. Brains are cool. All right. So oceans are dark below what depth? Okay, Yusuf, you go.
120.
Yeah, about 100 meters, because that's as far as the light goes. So yeah, you're close. All right. So ocean movements. Let's talk about this real fast. I'm watching our time. So ocean movements, click, I'm moving you. There we go. All right. What is the rhythmic movement that carries energy through space or matter? It's a term, a general term, moves energy. Jack.
Waves.
Waves. Okay. What kind of waves do we have in the world? Ocean waves, sound waves, light waves, electromagnetic waves of all kinds, right? So a wave is anything that carries energy through space or matter. So what is carried forward, transferred forward in an ocean wave? What's getting transferred forward? It's not water. What is it?
Energy.
Yeah, you said I was going to call it, but yeah, you got it. Energy. So energy is moved. The water is not moved. All right. So the water stays where it is. If you've ever looked at, anybody ever seen like a wave? You ever been to like sometimes museums have like a wave machine and it's just, you can see through it. It's like a cross section. If there's anything in there, like a little leaf or something, you watch the wave move and that little thing kind of bobs in the water because the water isn't moving. It's the energy of the wave. Eventually it'll push it, but you can watch that thing stay within the water for a while. It's interesting to watch. So what do you call the high point of any wave? What's it called, Liam?
Crest.
That's the crest of the wave. Very good. All right. And what do you call the lowest point of the wave? Any wave. Yusuf.
Trough.
Trough. Very good. So you've got crest, trough, right there. Okay. And the depth at which a wave disturbs the ocean water below. Do we know? Alex?
I believe it has amplitude.
Okay. Yeah, we were there. Yeah, but yeah. So we're talking about wave base. Okay. Wave base is what you call the depth to which that wave is going to disturb the water below it. All right. So here we are. This next one, the horizontal distance between adjacent crests. So you've got crest, trough, from here to here. What do you call that? Jack?
Wavelength.
Wavelength. That is wavelength. All right. I threw it again. And that determines the speed at which the waves move through deep water. Longer waves move what? Faster or slower than shorter ones? What do we think, Drew? Longer waves.
Well, I mean, the shorter waves move faster this way.
Right. Okay, yes. So you've got longer waves are going to move faster than shorter ones. If you watch them, they can just kind of push through versus right? All right. The vertical distance between a crest and a trough is
Amplitude.
okay, there's where you're going. That is going to be your wave height, and your amplitude is actually not from the trough to the crest, but where? From where? Do you know? Like the
Midpoint.
The midpoint to either end. Okay. So what is going to affect wave height? Okay. The expanse of water and wind that wind blows across. What does anybody know what it's called? This is
An ocean.
Yeah, kind of. So it's called a fetch, actually. So the fetch is the expanse of water that your wind is blowing across during wave action. And then things like wind duration and speed. What do we call the collapsing of waves? Yeah, that's a breaking. Okay, or breakers. So yes, what you see at the ocean when you're at the beach, those are breakers. They're collapsing, right? They do that at the ocean, in the ocean, when there's like a storm or some reason for there to be a lot of wave activity, right? Okay, so tidal range. The difference between the levels of high and low tide is your tidal range. The greatest tidal ranges in the world. Do we know where they are? Anybody know?
The Bay of Fundy.
It's the Bay of Fundy. Very cool. Where's the Bay of Fundy? Do you know? Anybody know? It's in Nova Scotia. It's not too far from where I just was, actually. In the movie that we will watch on Christmas party day, you will see some really cool video of the water going in and out at the Bay of Fundy. And there are all kinds of areas around the Bay of Fundy, little small areas where the same thing occurs, and it's incredible to watch. So moon tides. All right, high tides are caused mainly by what of the moon on the on Earth's ocean waters? What is it that causes tides? Yusuf, do you know?
The moon.
Yeah, what about it? Yes, the moon has a gravitational pull. Between the Earth and the moon, there's a gravitational pull, right? So that's what's actually causing tides, because the moon is going to pull the water towards it. If it's closer, it's going to pull the water even farther. And if it's on the opposite side of the Earth over here and nothing's pulling, that water is going to relax back down towards the Earth, right? So Earth's tidal bulges, are always aligned with, do we know? Yeah, the moon. Very good. All right. So think about how you've got the moon pulling on one side. It's going to give you a low tide. If the moon is closer, it's going to give you a low tide because it's going to pull the water away. If the moon isn't near you or you're on the opposite side, it's not going to happen. You're going to get a higher tide.
But the bulges were on either side. So if the moon is here, then the bulges are on either side of the Earth.
Yeah.
Yeah. There's some good. I'm going to find you some good, better images of it.
A lemon.
Yes, it makes it look like a lemon. You're right.
Because the
Pulling at
lemons
it.
have-
Depends where the water is located and where the moon is located, like in relation to one another. I'll get you some good images of it. We're not going to focus too high on it, but know that when you've got a full moon, what do you expect your tide to be? High. What do you think? Low. Okay, who thinks low?
Well,
Okay, who thinks high? Okay, why do we think low?
I just want to say I don't think it's going to cause a difference.
Okay.
How much the moon?
You got it. Everybody got it. Good. There we go. Okay, that's what I was looking for. Very good. But you can follow the moon cycles because it does give you an idea of where the moon is with relationship to you, and that can be used to tell whether you're tidal. A lot of the times when you have a more full moon, you do end up with a lower tide. Frequently. Notice. All right. Sun and tides. The sun acts in the same way as the moon, but how is its influence? Greater or less? Bailey? Less. What? Why?
It's farther
Way further away. So we have what we call spring tides. These are when high tides get higher and low tides get lower. And then we have neap tides. And that's when high tides get lower and low tides get higher. It's based on an average. Don't worry about it too much. So tides explained. I'm actually going to leave this one for you to watch. Okay. Because you can go back and watch it later, but I'm watching our time and I want you guys to have a little review time. All right, so gyres. These are these closed circular surface currents in the ocean. We have a Pacific gyre that's become kind of famous for what? Does anybody know?
Garbage patch.
What is it?
Garbage patch.
It is. It's an ocean garbage patch. All the stuff that gets left on the beaches or dumped in the oceans ends up in a gyre circling around. And you can actually go to one of the ones in the Pacific that's very well known, and it is full of trash. It's a giant circling trash pile in the ocean. Yeah.
I forget. No. Never.
That was a good one. All right. So moving on, we have, I clicked here. There you go. Surface currents. So these are faster. They're more predictable. They are affected by Coriolis effect and topography. And the force of the surface of the currents causes floating objects to move forward. This is your general pattern of surface currents on the Earth. Yeah.
It's like a big racetrack.
It does look like a racetrack. Yeah, it does.
So is the Bermuda Triangle a current or is it a trend thing? Forget.
The triangle's fascinating, though. It's fascinating. It looks like there's a cold subflow that goes right. You can see it kind of going through. Yeah, like right here-ish, right? I don't know. Great question. All right, so upwelling. This is when upwelling waters, what do they bring up to the surface? This is when cold water's moving up. What are they bringing up from the bottom? James. Salt and a whole bunch of other stuff, nutrients and stuff too that's down there, that's settled. Think about all the things that die in the ocean that leave organic nutrients behind. They sink because of gravity.
Cold, nutrient
Yep.
dense water.
Upwelling comes up, and that's how that stuff gets up there. And then density currents, these are caused by rising and sinking water. And we know that water is sinking when it's colder and saltier, rising when it's warmer and less salty. Rip current, this one I'm going to say for you to watch. And I'm going to tell you, please go home and watch this. Please watch this, because what this will do is it will show you what a rip current looks like. A rip current is when you're at the ocean front and the water's going in and out and in and out. And if you look, you can see a space between waves. And that's when you have a current that's causing the water to kind of suck out really fast. People die in rip currents all the time. You don't expect to get caught in them, and they will suck you right out into the ocean really fast. There are ways to spot one, and there are ways to get out of them, like methods that you should learn if you're going to swim in the ocean. This is how to get out of a rip current. So I will leave this for you. Please watch it if you ever go to a beach. It will it might keep you alive, so it's important to watch. So I'll leave these for you for later. Let's do a little review. Let's do a little review. Huh? I don't have Jeopardy yet. I'll have Jeopardy next week. What I have today is the answer review one. All right. So this is the same one that is available to you in your folder, right? In your resources folder. All right. So what I'm going to do is I'm going to go through them quickly, and here's what we'll do. We're going to go in order. You guys can try and answer, okay? Everybody's going to try and answer. If you don't know, just say, I don't know, because we're going to try to go fast. So we're going to go Drew, Liam, Caitlin. We'll do Parker, James, Chloe, Milo, Lily, Piper, Alex, Bailey, Jack, Yusuf, Sky, and around again. Okay, so who's first? Yeah, hi. And who's after Drew? All right, we're good. All right, first thing we're going to do here. Formal sciences, natural sciences. All right, Drew, what on here do you know? The study and property of matter and energy is what science? Do we know? The study of nature and properties of matter and energy. Which branch of physical science is that? Yeah, down here. So that is going to be, oh, sorry, I forgot this one, social sciences. But that's going to be physics. All right, what's the next one, Liam? Study of celestial objects, space and physical universe.
Astronomy.
Astronomy. All right, Caitlin. Study and identification of substances of which matter is composed. Do we know? Can always say pass. All right, it's going to be chemistry. And the study of physical constitution of the earth and its atmosphere is Parker. Do we know? Or pass? Science, got it. Okay, moving on. Excellent. Woo! All right, James. So how would you define space? Quick answer. Everything around us. So continuous area expanse, you can look this up, right? Available unoccupied dimensions. All righty, Chloe, how would you define time? This is a hard one. So you'd say it's measured or measurable period during which an action, process, or condition exists or continues. Basically, it's a continuum between one action and the next action. That's a tricky one.
Space-time.
Milo, how would you define forces?
Anything that.
Oh, that's a good one. Okay. So push or pull on an object is a good way to, or an influence or change that can change motion or velocity. Very good. So push or pull is it. All right, Lily, how would you define motion? Something that moves. That's pretty good. So it's a change with time of the position orientation of a body. So over time, the position of something changed. That's motion. All righty, Piper, how do you define matter? There you go. It's a substance that's going to take up space, constitutes observable universe. The last ones you want. Anything that has mass takes up space. All right, Alex, how would you define change?
A difference in something from before.
Okay, good. So it's a transition from one accepted theory to another, a process in which one or more substances are altered into a different substance. And the last one there, an alteration, transformation, modification, substitution. Those are good. All right, Bailey, how about energy?
How much of something it takes to change?
Okay, that's a good answer. So it's your capacity to do work. That's the big one. And the property of a system diminishes all these other ones. Usable power, capacity to do work is a good one to remember. What's this right? Whoa, where'd it go? Oh, this. What's this right here? That's our little like sub motto. Knowledge equals W over T. What's W in this case?
Work.
Work. What's T in this case?
Time.
Time. So knowledge equals work over time. What does work over time mean? Does anybody know what it means?
How much work you put in something?
There's another word for it. Do you know?
Work multiplied by time.
Work. Yeah. So what is it?
Energy.
Power. So knowledge equals power. Ah, we got it now. Okay, your big ideas in earth science. Jack, you're gonna get the first one here. Well, this isn't anyone here. This tells you there's no blocks in here. So systems, energy, life in the environment, unchanging drives. This is a big one. The unchanging drives change. Okay, keep that in mind. It might be on your midterm. All right, Jack. What is an organized plan for gathering, organizing, and communicating information?
Scientific method.
Scientific method. Very good. All right. Goal of any method is to solve a problem. All right, Yusuf. The information you obtain through your senses. What's that? Your information you're obtaining from your senses. You're looking around or listening or smelling. Do you know what that is? Observation. Oh, sorry, Sky. I bumped your question. I know you knew that one too. So an observation and then a hypothesis is your proposed answer to a question. All right. Doesn't go one way. It moves around. Okay. How about we'll do that in. Okay, can be manipulated by the experimenter and can change in another. What do you change in your experiment? What do you change? Do you know? You remember? Yes, that's my girl. Independent or manipulated variable? We usually say independent. That is what you change. All right, Drew. What changes? What do you observe?
The changing is the control.
Nope. Dependent. What you change is independent. What you observe changing is your dependent. And then Liam, what's your standard for comparison?
Control.
That's your control. Very good. All right, great. That's remember forever, right? Ridiculous. All right, developing a theory. What is a rule or principle that always works under the same conditions? Caitlin, do you know what that is? That's a law. And then Parker, a well-substantiated explanation for something. What's that one? Not a law, but it's an explanation. Close. Theory. We have theory versus law. So scientific law, oh, everybody do it with me. Say it aloud. Scientific law tells you
What happens?
happens a truth, right? And, or a fact, you could say. And scientific theory tells why, an explanation. Memorize those two for the rest of your life, right? Yes, for eternity. There it is. It forever and ever. All right, this is an easy one, I think. James, what do we call this system? Metric or SI units. All right.
The system we don't use for some reason.
Which is going first? Let me see. Okay, we're going this way. So this is, we measure in meters. Chloe, what's mass going to be? Do we know? Volume is great. Gram is how we use that. Yeah, mass is, we're going to use gram. So it's really kind of like weight, but not really weight. But weight, we also measure in, Milo. Do you know? It's going to be the same as mass in this case. It's going to be grams. We measure both mass and weight in grams. But remember, which one of these is dependent upon your position in space? Alex?
Weight is
Weight.
dependent upon where you are.
Yeah, your mass never changes because it's always what's made up of you, right? So what do we use for area, Lily? Do you know? Area is 2 dimensions. So it's like length times width. So what are we using there? Do you know? So that one's going to be meters squared, length times width. How many meters this way? How many meters this way? So Piper, what's going to be volume? Meters cubed. Sometimes we'll do like centimeters cubed, that kind of thing. All right. So density, how much mass is contained in a space? What is that? What do we use there?
Grams per meter.
So that, yeah, kilogram per meter cube. Very good. All right. Bailey, time. Seconds. Perfect. And Jack, temperature.
Celsius.
Typically degrees Celsius. Very good. All right. So which one of these is going to go first? Let me see. All right, Desi, what is this one, Yusuf? What goes here? We're going backwards. Desi divided by 100. So we're starting at a unit here, and then we're going backwards, like decigram. Smaller than that is the
No, centi.
centi. Very good. All right, and then Sky, what's the next one? This one. Oh, it did. I'm sorry. Deci, deca, centi. Okay, so you're here, Sky. What's times 100 over here? Do we know? Okay, so that's hecto. We don't use that one too much. All right, so then this one over here is going to be, Drew.
Is that divided by 1,000?
Yep,
That-
Millie. And then lastly, over here. All right, Liam. Pass. That's going to be kilo. All right, get those in your head. There's a little, chart in your notes that you can look at. And remember, this is another way to look at it if you want to see it in scientific notation. This 3 exponent thing, remember why we put the commas in numbers? We put them right here for a reason. Ding, 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 ding. Whoop. And we put them there like that because in 3s. We do it in 3s because that's how many zeros, right? All right, so never forget, no matter who says otherwise. What are we saying here?
Science is never settled.
Science is never settled. All right. So who am I on? Am I on Caitlin now?
Yes.
So remember these 3. You don't have to answer this one because it's here. Presumes it's in a binary state. Presumes poor understanding in one area and validates good understanding in another. And then lastly, it's not about absolute proofs. It's about what? Narrowing uncertainty. That's the ones to remember. All right, Caitlin, let's do this one here. According to the laws of thermodynamics, there are 3 types of systems in science. Oh, open system, you don't get to do that one. Closed system and isolated system. No open and closed. You don't necessarily have to know isolated that well because it's kind of hypothetical anyway. So no open and closed. You may need that for your midterm, just saying. All right, what's this one, Caitlin? So you have your crust, your mantle, your inner core, and your outer core. What is the study here? What is call this whole thing? It's got sphere at the end. Something sphere. Shoot. It's going to be your close. It's gonna be your dropping everything. This one's gonna be your geosphere.
Butterfingers.
I know, for real. And next we have, let's do these next couple. We got 1 minute left. All right, Parker,
Go,
the
go.
gases around Earth are the atmosphere. It says it right there. Yep. All right, James, this next one. The water on Earth is the hydrosphere. Very good. All right, Chloe, what's next here? And all the living things on Earth. Biosphere, you got it. Okay, remember those. They might be on your exam, just saying. All right, so then I want you to know how to read latitude and longitude. You may be given a map and it may have a location on it. And you may be asked to tell me the approximate latitude and longitude. Be able to do that. Know that the equator is 0. Okay, that's the important one in life. Equator is 0. And the prime meridian is 0 with longitude. How do you remember latitude and longitude?
Latitude is a ladder.
Right? Runs horizontally is longitude and the ladder is the steps. James, there's a song on YouTube. I think you said that last time too. All right, so listen, it's time for you to go. Listen, your homework is to study and work on your lab. There are parts of your lab you're going to have to do at home. Next week, you are not going to, hang on. Next week, you're going to be studying for your midterm a lot. You're not going to want to take that lab home and have to spend hours and hours doing stuff that you could have done this week. Okay? So there are questions on there even about next week's documentary. If you can answer them by research, answer them. Alrighty? Good? And I will let you know as other things get added to your resource file. I'll send you an announcement. Have a great week. And here's your change if you want your coins. Do-do-do-do.
I've got a question.
Yeah.
One of life's many questions.
What if life's, I don't know if I know yet.
Like Goofy can talk.
Okay.
Can I have your phone?
Yeah. Did she stand by me recently?
No. Yes.
Is Pluto a dog? Then is Goofy a dog? Yeah. Uh-huh.
Why can some people like go like
Goof-
a whole?
Goofy was
I guess this is biology.
Goofy was a dog that was experimented on.
that's a good answer. Go their whole lives. like,
Goofy is a war
smoking a
crime,
cigar
but
and,
we
like,
love him
having
for it.
And not
A
having
lot of
money.
whiskey like every day.
Yep.
And not like
Not being
die,
genetic.
not affected. It's genetics.
It's just genetic.
And like some people try to vape it.
My
because-
grandmother smoked like a chimney her entire life, drank like a fish her entire life. She lived to 86 years old. What got her was eventually pneumonia, which she got frequently, but she had no cancer. She had no cirrhosis of the liver.
That's what happened to the oldest person
Hmm?
who lived.
There's also something to
120.
say, oh yeah, there's also
That
something
guy
to
has a
say
honey.
for that generation
Mhm.
and what they were exposed to when they grew up. So she was born right before the Depression, so she grew up in the Depression, and those people had to struggle. And they're somehow, keep it, yep, keep it. They're somehow tougher than we are. It's kind of crazy, but they are tough.
That was half the question that made no sense because I confused too. Like
Mhm.
the smoking one is like
Yeah.
some people could just go and like
Yep,
fine,
some people
but
just
some
smoke
try
forever.
and just get
Yep,
cancer.
without a single problem, and it's weird. It's super weird. You're right. All right, you guys, I will catch you later. Have a wonderful, wonderful week. Outstanding. Right. Is it live?
Yeah.
Live? Cool. You know, you like, you're all that way. Isn't that?
Red Bull today, all going good.
Oh, that's showing my watch.
Yeah. Well, the whole reason I went to the place today was because.
There's one right up here somewhere, and it's here, and that frequency on it. And I found right here, like, these are people that aren't started like 19. Mid-century modern, they're all here. Yes, this is called resetting back to reset. But we have to, you do not need to take time. Yes, yes. So we. Up until the first year after you. The real tree, you might just call one to this day, but if you're gonna get a real tree, the face is gonna be wide enough, or it can put out here, and it's done. So what I look for was like a pencil tree or a super round tree, and this one is super round, it's like 30 some inches wide, and it's 12 feet, it's 5 feet. And it fits in the attic upstairs. 5, 7 feet. Yeah, we did that too. We did that too the first year we were here. We got a beautiful big tall tree and. And it's super cool. No. Fun. Yeah, maybe I'll give you guys some more fun, like waiting in line for it. Yes, you're super on point. Yes. Did you get any cookies? They're okay. Awesome. So my dad was coming for Christmas again, because I heard this year. Yeah, I thought this year he doesn't take my meds anymore, they have to go back. Well, my dad, he stayed for last Christmas, and then put all my bills down for free and then I down and grab it and then put it on mine. He was not good. Because at the moment I was on the way and he didn't buy it. So he started wanting it for 12 hours straight. And it was like a confessional, y'all. He admitted everything we ever done in his life and we felt bad about. I'm serious. We talked about some guy he did one day and he's real mad because his wife was working pre-married again already. So they went and got paid off their farm and then they took the pig to the wedding reception and let it go. I mean, that's weird. And then I don't have any and I mean, he's really relationship. I don't really want to love that about him. It all up. He was insane. Yeah, a lot of those, not big haircuts. There are a lot of haircuts. And every year I get different ornaments for my family. I want to get them. Oh, the Sarah mentioned? Yeah, that's very fun. Fun and not fun. They'll fix anything, but they'll make you, they'll make you fuzzy and nuts and, yeah, craziness, crazy. You got your tree up at your house? You did, don't you? No, not yet. Are you doing it? Oh my gosh, amazing. You came off her, officer. So she has a necklace she made out of a pelvis that she found. It's I think it's a possum, maybe, and it's very cool. Oh, amazing. Love that. I was really amazing. I have to use that structure. Right, Dave. Well, you're at next week, and you can eat all the skip. I was just like that, when I think that, up near what we did, in the row. I know you can get there, even though everyone like to go, he's here. Yeah.
Great. You think you can buy a house and take your risk? But yeah, you think about that for me. That difference we call it one. Right. Yeah.
Yeah, it's not.
I don't know if it's ended the same album. Although it does have like a chip in it or something, so you can start your design board.
Yeah.
I would say, so like I like cards, right? I think when I'm moving, I'm really gonna like guns. And I'm not huge on jewelry, but I do like watches. So it looks like all the things I like hobby wise, are pricey. Cars are expensive, right? Parts are expensive.
No, we did.
Guns are pricey. Cause I like shooting and I wish I could go more often. And I just love them, and I love all the like the siren looks a little on something like something like a little box. That's all.
And ever find people. Yes, right, it's usually like a couple of dollars. Because I have a lot of it, the kid, one kid.
Yeah.
And then.
Debatable.
Yeah, what are your?
An idea, but I don't know. I don't know if it's a good. I think I'll give you one, but I don't get anything. It'll be a little smaller than this box, but it's so big and it'll be kind of like.
Yeah, it's the last one. Keep it and work out as much as you can at home. You're gonna need to, the phone that you text me from, typically, your phone, or you got it? I'm gonna make sure they get it from. Right in there. That's your mom, this one right top is your mom, dad, and Yeah, I don't like you. He works from home a lot. Yeah, that's my husband too. He's actually in Toronto right now. Future husband because he's bad. His battery is done. Pretty basketball. Yeah, Parks and Rec there. Uh-huh. Okay, yeah. Nice, got it. I think your mom said that was 1:45, so we probably here in 50 minutes. Paul, are you over there? No, okay, need to break down chairs and things, so. Alright, hey buddy, can you help me with the table and the whiteboard and the chairs and the table when you get a second? Yes, you. Andrea, you can help too. So you said you can do if you want. Can you help me break down? Folding chairs?
Yeah, you can start, I'll be right there.
Yeah. Okay, there, 2 more weeks. Get there. We all finish it by here. Okay, so.
Going inside, what mom? What table are you talking about?
You're my sweet boy. I didn't turn this off. I'm an idiot. Okay. Hello, whoever still listens. I'm an idiot. Yeah, 1 second. I'm shutting this